Helium neon gas laser. It is invented by Ali Jawan in 1961. It's a gas laser, gas jet laser. This is the diagram of the helium neon gas laser. It consists of approximately 1 meter size of the quartz tube. In this case, the pumping system is electrical discharge. In the electrical discharge means it gives a high potential in gas, then it gives a discharge, then it collides with a helium neon gas molecules and excited to the excited energy level. How to construct the helium neon gas laser? We already consist of a quartz tube of it is approximately 1 meter length. The helium neon consists of a gas discharge quartz tube with a length 80 centimeters. The diameter is approximately 1 centimeter. Diameter is 1 centimeter. The length of the tube is 80 centimeter or approximately 1 meter size. In the tube, that is I already mentioned, that is a quartz discharge tube. It is a quartz discharge tube filled with a mixture of gas, that is helium and neon. That is a mixture helium and neon gas. Okay, the tube is made up of the quartz material. It can operate up to 1000 degrees centigrade also. It cannot break down. Normal glass, it breaks it or soften it below 500 degrees centigrade. Quartz has a high melting point and high softening temperature that is above 1000. The helium neon gases mixed with a different pressures. Okay, helium neon gas we are filled in the tube at a pressure of 0.1 millimeter of Hg. Okay? And helium gas under the pressure of 1 mm of Hg. That is different pressures means it will different ratios of the gases. That is 10:1. The ratio of the helium neon gas mixture is about 10:1. That is the number of helium atoms greater than the neon atoms. So here also that is neon gas is at the pressure of 0.1 mm of Hg. Helium gas at 1 mm of Hg. That is very low pressure means we can inject or get filled with a low number of gas molecules. That is neon molecules are low compared to the helium gas molecules. That is the ratio is 10:1. The ratio of the helium neon gas mixture is 10:1 in quartz discharge tube. Okay, the output power that is depending upon the discharge tube voltage and pressure inside the gas molecules. How much of the electric discharge voltage supplied and what is the ratio of the gas mixtures. What is the pressure ratio of the gas mixtures. In this we are taken as ideally 10:1. 10:1. We taken as 10:1. But we have to vary with some 8:2. It gives a different wavelength or different emission. So 9:1. Okay, it gives a different spectrum. It is the emission, the output power or output wavelength is depending upon the discharge length of the discharge tube and pressure inside the gas. Okay, that is here it is a pumping source, optical pumping. In Ruby laser, we had used the optical pumping, which is xenon flash lamp used in laser, Ruby laser. Here, the pumping source is electrical discharge around the voltage at 1000 volts. Okay, at this voltage, we can flow the current 5 to 100 milliamperes. Okay, for continuous wave operation, we can apply the voltage discharge voltage 100 volts and a current 5 to 100 milliamperes for continuous beam of operation. Okay, the optical cavity. Okay, in this case, that is a 3 different components. One is active medium is helium neon gas mixture. The pumping is electrical discharge. One more last one is optical cavity. Okay, in the optical cavity, that is plane. One side is highly reflecting mirror and other side is partially reflecting mirror. That is partially 1% transmission of the other end. This is about the optical cavity. We have a special arrangement in the tube. Other one side is highly reflecting mirror, other side is partially reflecting mirror. This acts as a optical cavity. It's partial and fully reflecting surfaces both the end. Then it acts as a optical cavity. Electrical discharge is acts as a pumping source. The active medium is helium neon gas mixture. Okay, this is a black diagram of the helium neon gas laser. With these two, this is a partially reflecting. This is a partially reflecting mirror, and it is fully reflecting mirror. Okay, we can fill the gas at the ratio of 10:1 at the pressure of 0.1 mm of Hg is neon gas and 10 mm of 1 mm of Hg of helium gas. It is a positive. This total is positive, approximately 80 centimeters length, and diameter of the tube is 1 centimeter. Okay, these are the two discharge electrodes that here I apply the voltage approximately 1000 volts. So the discharge voltage I apply 1000 volts. Okay, these are the partially reflecting. This is the fully reflecting mirrors to act as a optical cavity or resonant cavity. Okay, there is a laser beam output from this end. This is a black diagram of the laser, helium neon gas laser. Then next move into the working, how it is work and how it is produced a laser beam. This is the energy level diagram of the helium neon gas laser. Okay, I already mentioned it is a four level energy system or laser system. This four level means four different energy levels. 1, 2, 3. Okay, initially, we are giving electrical discharge to the electrical discharge. Due to the electrical discharge, then the discharge energy observed by the helium atoms. This helium atom excited to this state, two more helium atoms are excited to this state. Then from these H3 and H2 helium atoms collide with a ground state neon atoms. Because this collide with a ground state, this collide with a ground state. Okay, due to the collision of He2, then few more electrons move, neon molecules move to Ne4 state, and few more move to this Ne6 state, energy state. Due to the collision of helium, He3 and He2 collide with a ground state neon atoms. Therefore, there is a perfect inelastic collision. Therefore, they exchange the energy total to the neon molecules. Therefore, neon molecules excited to the neon gas molecule excited to the this Ne4 state and Ne6 state. The process is given by reaction equation. This is a reaction equation. Star represent the excited. Once first initially excited the helium atoms. Helium atom. Therefore, these helium atoms collide with a neon set ground state. Okay, there is no star means it is ground state only. Therefore, perfect elastic collision takes place. Therefore, then helium atoms comes to ground state and neon atom move to excited state. Okay, the emission of some energy. Next, how it is working there. Okay, I will mention that is electrical discharge. That is electrical discharge passed through the gas mixture. Okay, the accelerated molecules are generated. Therefore, these accelerated electrons collide with a helium atoms. Okay, electrical discharge means the high energetic electrons move from one electrode to other electrode. During the movement of the electrons from one electrode to other electrodes, they collide with a helium atoms. Okay. Therefore, the collision takes place. Then these helium atoms excited to the higher energy levels. Okay, since they are metastable, helium atom spend more time, sufficiently long time, and they collide with a neon atoms. Same time, they collide with the neon atom. First, due to the electrical discharge, the electrons collide with the helium atoms. Helium atoms move to this E2 state, He2 and He3 state. Okay, they have these two states are metastable states. Metastable state means the lifetime is more. Okay, they have a stay back at some more time. Therefore, while it comes down to ground state, they collide with a neon atoms at ground state. Collide with these helium atoms. Collide with a neon atoms which are at ground level Ne1. Okay, due to the perfect inelastic collision, the total energy exchanged to the neon atoms. Therefore, the neon atoms excited to the higher energy level, that is, one is Ne4 level and one is Ne6 level. Okay, from that, the atoms are de-excited. De-excited to ground state, that is Ne1 state. Okay, initially, due to the electrical discharge, that is highly accelerated electrons collide with the helium atoms. Therefore, helium atoms are excited to the excited energy level. Excited energy level. While you are coming to ground state, they collide with the perfect inelastically with neon atoms. Therefore, due to this collision, neon atom excited to excited energy level Ne4 and Ne6 atoms. Therefore, while coming to the ground state Ne4. Ne6 and Ne4 are the metastable states. That is the first condition to generate the laser light is to achieve the population inversion. To achieve the population inversion. Therefore, this Ne6 and Ne4 is acts as a metastable state. Therefore, we can achieve the population inversion from Ne1 state to Ne6 and Ne4. Means more number of neon atoms excited to the excited energy levels compared to the ground state, that is Ne1. Okay, from that place we can produce a stimulated emission takes place in between Ne6 and Ne6 to Ne3. Okay, which gives the laser wavelength of 6,328 angstroms. Okay, next one more stable state Ne6 and Ne5. It gives a wavelength 3.39. This is IR region. This is a IR region. This 3.39 micrometers is a IR region. Okay, one more transition, that is Ne4 to Ne6. This also give the infrared radiation, that is 1.15 angstroms. This is also IR radiation. After that, from Ne3 state to Ne2 and Ne1, these two transitions. Finally, neon atoms return to ground state with a non-radiative diffusion and collision process. But that is one. Okay. From this, Q is transition from this. Okay, it is a 3.39 micrometers. Okay, Ne6 to Ne3 transition gives the visible laser light, that is approximately 6,328 angstroms. Okay, then one more transition, Ne4 to Ne3. Okay, that gives a 1.15 micrometers. Okay, from the next, this is a spontaneous emission. There is no laser light. From this Ne3, Ne2 to Ne1 be excited to ground state, which normal or radiation less transition takes place between Ne2 to Ne1. Only the main transition is one is Ne6 to Ne3. It produces a visible light, that is red color, 6,328. If we require the infrared radiations, then we are taken as Ne6 to Ne6 to Ne3. This transition. If we require 1.15, we can this. Normally, we general purpose we use the visible spectrum. Then we can remove this infrared wavelengths 6000 and resistor by using the observers placed inside the discharge gas tube. Okay, after arriving ground state, again collide with the helium and rise it to this is a continuous process. We can produce the continuous output from the helium neon gas laser. We can place some optical elements which observe the infrared laser wavelengths. These IR observers placed inside the discharge tube to observe the wavelengths of 0.39 micrometers and 1.15 micrometers. Hence, we can give the output as a single wavelength that is 6328 angstroms. Okay, that is the power used is about the very few milliwatts. Output power is that is few milliwatts. The wavelength is 6328 angstroms. What is the applications of the lasers? Okay, in all ferrometric experiments, metrological applications, barcode readers, image processing, holography. There is 3D images produced and reading by using the helium neon gas laser. Okay, moving to the one more gas laser, that is CO2 laser, or it is called as molecular gas laser. Okay, it's a carbon dioxide laser is invented by the Indian origin one fellow, that is CKN Patel, 1963. 1963. Okay, it produced a high power laser beam. Okay, CO2 laser belongs to the molecular gas laser. Okay, it produces a high power laser beam. Okay, this is a construction of the CO2 gas laser. Okay, it is also same discharge tube, large discharge tube. We have to mix with the helium, nitrogen, and CO2. The major active component is CO2. The active medium is CO2. It can support helium and nitrogen. Okay, this is a large discharge tube. Okay, it can evacuate. Okay, it is a fully reflecting mirror. It is a partially reflecting. Okay, NaCl booster window. Okay, it produces a laser light. Okay, that is, it consists of a large tube of 5 meter long and 2.5 centimeter diameter. This discharge tube with a filled gas mixture. In helium neon gas laser, the mixture is helium and neon. But in the CO2, it is a mixture of CO2 and helium and nitrogen gas with a different pressures. CO2 is 1, CO2, nitrogen, helium with the pressure ratios of 1:4:5. These are pressure ratios. The terminals of the discharge tube is connected to DC to a DC power supply. The other discharge tube fitted with a NaCl booster window. So polarized light. You can produce the laser light is polarized. Okay, you can place a two concave mirrors. One is fully reflecting. This is a concave mirrors. One is partially reflecting mirrors. Acts as a optical resonator. The optical cavity. Okay, here it is a different helium neon gas laser. It is in a helium neon gas laser. First, helium atoms are excited to excited state, and while coming down to the ground state, they collide with the neon atoms. But here it is the transition between the rotational and vibrational energy levels of the CO2 molecular gas. Then it produces a laser. That is, nitrogen atoms are raised to the excited state, which can deliver energy to the CO2 molecules very close to the energy level. The transition takes place between energy levels of CO2 atoms, then it is laser beam. And I will show next slide how it is produced. Okay, there is a different modes of vibration of the CO2. molecules. Okay, the C2 share with a 2 oxygen atoms. So this is a CO2 structure. If it is a different modes, 3 different type of modes of vibration takes place in a CO2, symmetric stretching. Symmetric stretching means carbon atom picks the only oxygen atoms are vibrate in this direction. This direction like this is a symmetric stretching. Okay, C is symmetric. In symmetric stretching, symmetric mode, C is stationary. Only the oxygen vibrates simultaneously along the molecular axis. This is a molecular axis. This is a molecular axis. Okay, vibrate along the molecular axis. Next one is bending, CO vibrating perpendicular to each other. This is in this direction. This is CO2, oxygen, and this oxygen, carbon oxygen also. This CO2 is perpendicularly molecular axis. Here it is vibrate along the molecular axis, bending perpendicular. Asymmetric stretching. Okay, in asymmetric stretching, it is opposite to the symmetric, means the carbon molecule also, carbon atom also vibrate along the molecular axis. It's already oxygen in this direction along this direction. This is asymmetric stretching. Okay, when you have to take the ground state, first initially nitrogen atom excited to the excited energy level due to the gas discharge tube. This energy transition to the asymmetric stretch vibrations of the carbon dioxide molecule. Therefore, from this is a 001 asymmetric stretch mode. Therefore, from this you can transition. This is one more laser emission, that is asymmetric mode to bending mode, asymmetric mode to symmetric mode. If you have to take the transition from asymmetric to bending, asymmetric to symmetric, the emission different wavelength. This purely higher wavelengths, approximately this is 9.6 also near to the higher is 10.6 micrometer is higher wavelengths. You can be excited to ground state with C00 ground state. Essentially, nitrogen atom excited to excited state. This excited nitrogen atom collide with a asymmetric mode carbon dioxide molecule. Then transition takes place from asymmetric to bending, asymmetric to symmetric. This is a one transition. This is a one transition takes place. It is only due to the laser emission 10.6 micrometers and 9.6 micrometer. This is about the working of the CO2 gas laser.